Make a start now. So good afternoon, everybody. My name is Simon Corby and I'm Director at the Alliance for Sustainable Building Products. So welcome to our event this afternoon. This is our Innovation Pitch Series grand finale. So welcome to that and let's strap on in and off we go. So the program for today, we're going to have 5 minutes with myself and then 5 minutes with Richard to give you a bit more detail about the series to date. And then we've got 6 contestants battling away for the grand prizes. So they've got 4 minutes and 4 slides. And then we've got 4 minutes question and answers from judges and 4 minutes questions from yourselves in the audience. So if you can put your audience questions into the Q&A, we'll go over that in a minute and we'll pick questions from that. And then following the presentations, we're going to give you a little bit more information about our Reducing Plastics in Construction group and the work that we're doing there. And Catherine's going to talk us through that. And then we're going to ask you to you, the audience, to try and pick your favorite. And then we'll go to the judges and ask them to consider their verdict and who they think should win. And we'll announce the winners and finish up promptly at 4:30. So I'd just like to introduce the judges and say a huge thank you to them for giving up their time this afternoon. So Neil Freshwater is Public Affairs Manager for Velux, and they've been kind enough to sponsor our expo and conference this time around. So thank you very much for that, Neil. And then Julie Godfroy is a Director at Julie Godfroy Sustainability. She's also part of CIBSE. And Julie has many different skills, a deep range of skills. Most recently, she's been writing guidance on building performance evaluation for social housing providers and how you might look at doing that. And then last but not least, we've got Mark Lynn, who's our Vice Chair and Managing Director at Thermofleece and Eden Renewable Innovations Limited. So they do a range of different insulations, including a recycled PET plastic insulation. So many thanks to all of our judges for coming up and offering your time. So just a few instructions. So any questions to any of the pictures, put them in the Q&A. So we're just going to have 1 question from the judges and 1 question from the audience each time around. Don't raise your hand because we're not really monitoring that, and any technical questions, just pop it in the chat. So just be wary of that. So who are we? So the Alliance for Sustainable Building Products is we're a not-for-profit mission-led membership organisation, and our mission is to accelerate the transformation to a healthy, low-carbon built environment by championing the use of demonstrably sustainable building products. So we think that really healthy buildings really start with healthy products, and we think that a healthy planet starts with healthy products. So really that's our focus is at the product level. So we are a knowledge sharing organisation, and we aim to do that through our briefing papers, and we've got many of those on our website, events, and we've got lots of research that we're undertaking to try and push the industry forward. We're looking at product standards like EPD and Nature Plus, and we respond to consultations and much more. And these are our 6 pillars, different sort of work streams, but of course it's not silos. We try and make sure that we're intertwining all of these different subjects at the same time because they all make up the sort of broader picture of sustainability. Yeah, so we launched in 2011 at the Palace of Westminster and started off with just a few members. And now some sort of nearly 10 years later, we're up to 80 members and counting, and we aim to get to about 100 by the summer. So take note, Larry. And so this is our membership list of logos. So a big thanks. I'm just going to pull out a few, but thanks to all of our members because you've helped us along the way for our mission. But I'm just going to pick out Wienerberger as being patron members since the very beginning and stayed with us all the way through. Archetype, so Ben Humphries sits on our board and has a tremendous contribution to all of our work. And Cleveland Steel and Tubes, who are also patron members. And there are many others I'd like to say thank you to, but thank you to all of our members. So do get involved with the Alliance for Sustainable Building Products, join up as a member or sign up to our free mailing list, become a sponsor or input into our working groups. So keep an eye on our website and newsletter for what's coming up by way of events. And we've got a team of 5 now, so our contact details are coming up there. And just lastly, we've got a research project on the go. Yes, that is a European flag. So we caught the last train out of Waterloo for Brussels, and are working on waste duvets as a sort of problematic waste stream, so understanding what we can do with those. So brilliant. Well, thank you so much. There's our contact details. So I'm going to hand you over to Richard now to put a bit of detail onto what we've been up to within this series. So over to you, Richard. Thank you.
Okay, thank you, Simon. Right, I'm just going to do a very quick roundup of the series and the preliminary events. So the series, it came out of our reducing plastics in construction group, which is Catherine will talk on in a bit more detail later on, but it's a cross-sector stakeholder group of some of our members, and essentially it's trying to share knowledge and learning and reduce the overuse of plastics in the construction industry. So we came up with this idea of a Dragon's Den style event program, and we had the first one back in June. We've since had 5 rounds looking at different product types, and we've had over 400 attendees, 15 judges, 15 innovators, and 7 winners. So these are our judges, so a big thank you to them for lending us their time and their expertise. It must be a really tricky process to come up with some good questions and decide on their favorite. So thank you to all of them. And these are our innovators. As I say, there was 7 winners. We've actually just got 6 today, as one has unfortunately had to drop out. We've got these 6 fantastic companies, 1 from each of the rounds. We've actually got 2 from the paints and finishes round. So really looking forward to hearing their presentations. But thank you to all of them for entering. They're all brilliant. And this is what they can win. So we'll do some good promotion of their product on our website and social media. There's mentoring opportunities. We can match them up with our members, so some big contractors and architects. They can have access to our training, and we can also do a dedicated webinar with them, with our winners. And this is how you can get involved. So we'll have an audience poll at 4:15. So you'll have heard all the 6 finalists. We'll open up the poll, and you'll have one vote to let us know your favorite. But please do keep adding your questions to the Q&A throughout. We only have time to ask one, but we'll ask our finalists to type in some of their responses throughout the event. So I think that should be it. Thank you, Simon. Are you there, Simon? Not to worry. I think so. First up is Biome. Iab, if you are you there? And are you okay to show you? Oh, there we are.
Yes.
Brilliant. Thank you.
Hello, everyone.
All right, I'll start the timer. And
good afternoon, everyone. I'm Iab Syed, founder and director of innovation at Biome, a multi-award-winning research and development-led company driven by a very simple philosophy: allow nature to lead innovation and only have a regenerative impact on everything we touch. Last year, we won the insulation category of the ASBP Innovation Pitch with our carbon negative, 100% natural and high performance mycelium insulation. Mycelium is the root structure of mushrooms, usually buried underground in forests, holding all the topsoil together. Whilst mycelium has been used for centuries as a material and otherwise by ancient peoples, our in-house team of leading scientists, designers, and engineers have developed novel ways to evolve mycelium species and collaborate with them to create the ultimate building insulation material. Our mycelium insulation is outperforming leading synthetic and natural market alternatives with a score of A+ for VOCs, the highest ever rating BBA has seen, a heat of combustion of 16 megajoules per kilogram, making it twice as effective at slowing the spread of fire in a building, and thermal conductivity values as low as 0.024, competing with the most premium plastic insulation and outperforming natural insulation by 2 to 3 times. No additives, no chemicals, no coatings, no extractive processes. In fact, the production process sequesters carbon, outperforming market leaders by simply using nature's genius. To achieve such advanced properties, we follow nature's lead, and we evolve and train our mycelium strains accordingly. We also train them to consume a variety of waste streams and byproducts from agriculture, food, construction, and fashion. As the mycelium grows to form an insulation panel, it needs nutrition, and we encourage our strains to build an appetite for problematic excess resources that are at the heart of our waste crises. We had a revelation in our labs a couple of years ago where we discovered that one of our strains had developed an appetite for plastic. So not only is our high-performing mycelium insulation competing with high-performing plastic insulation, our mycelium strains can literally consume it. We won the Waitrose and Partners Plant Plastic Prize in 2019, and we've now developed strains of mycelium that can successfully consume polyurethane and polyethylene, covering the world's most used and problematic plastic products, from building materials in, yes, plastic insulation, to your kettle, toaster, plastic bottles, films, and packaging. Now, as we are developing such groundbreaking technologies, we wanted to make sure that they are commercialized and brought to the world in an ethical and socially equitable manner. So we're setting up our production facilities in collaboration with local communities and social enterprises, offering them a 50% profit share on all materials sold to be reinvested into local education, entrepreneurship, and infrastructure projects. Our first production facility, known as Biomill Watchet, is now set up in Watchet, West Somerset, one of the UK's most disadvantaged yet wonderful communities. And we're on a rapid scale-up trajectory with 2 more biomills already scheduled for the UK within the next year, as well as others in Europe. Each biomill will eventually produce enough insulation for 120 homes per month, consuming around 240 tons of waste and sequestering at least 30 tons of carbon every month, creating hyper-localized carbon sinks that are catalysts for local economic regeneration, restoring local equity, and building social and economic resilience. At Biome, we tackle the world's greatest challenges with holistic and systemic solutions. Mycelium insulation is certainly not all we do. We have also developed a sheet material made out of food and agricultural waste, which is being developed into a plant-based concrete and a nature-inspired construction system that embodies the circular economy. We're engaged with some of the world's largest multinationals and are supported by top universities, government, national and international bodies, all symbiotically and collectively working towards securing a more compassionate and equitable nature-inspired future, the future of home.
Right, thank you, Ehab. Well done. I don't think you drew breath in the entire time.
I know.
So you must feel slightly lightheaded now. So fantastic. Thank you so much for that. So we've just got now to move on to our judges. So I'm going to ask Julie to step forward and perhaps ask Ehab a question, please.
Thank you. You might have covered it at the speed you were, but if so, I missed it. What happens at end of life?
So at end of life, you can either feed the material back into the same production process, because mycelium are cannibals, or you can compost it, cold compost it, offering pH balanced nutrition to the soil.
Thank you.
Okay, so that was a very quick answer. So any of the other judges, Mark, got any questions that they want to ask?
Yeah, Simon, I'd just like to ask what the conversion rate is for plastic as a feedstock.
And do you mean by that, Mark, the degradation rate?
Well, you feed the fungi plastic, and they digest the plastic. What percentage of that plastic do they digest? If they don't digest 100%, what happens with the remaining feedstock?
Right. So before we're actually able to use plastic as a feedstock on a large scale, we still need to undergo a bit more research. So at the moment, we're able to consume 100% of any mass of plastic within a space of 8 years. We've had some experiments that showed 2 months, which were anomalies. We don't want to claim that yet. We need to do a bit more research on that. But within the 8 years, it consumes the entire amount of plastic, converts it all into hydrocarbons and sugar. So there's no plastic left in the material. And any mushrooms that grow, if you want to use that approach, you can actually consume that. So it's completely free of any other toxins or the plastics.
Okay, lovely. I think that answers your questions. So audience, it's over to you. So really, this is your opportunity to quiz EHAB. I've got nothing in the Q&A at the moment. If you can start firing your questions off and pop them in the Q&A. I'm just going to put Neil on the spot then to take up the slack, because we've got a little bit of time for more questions. So Neil, perhaps I can ask you to pose a question to EHAB.
Yeah, it's just a general question. In terms of your production, what's your kind of energy consumption like, and how does that perhaps reflect on the kind of net carbon footprint of the product?
Absolutely. So the process is a bit of an ancient process. It's incredibly simple. It's incredibly low energy. We're actually using the living organism to do the majority of the work. So we're still currently running life cycle assessments because we're constantly optimizing our production process, and we're still undergoing trials at the moment. We haven't got exact life cycle figures for the energy, but when you compare the embodied energy in mycelium to any other insulation product, at minimum, it's 10 to 14 times less energy than any other insulation product on the market.
Okay, thank you very much.
Okay, so we've got a few questions that have started to come in now. So we've got time for maybe one question or maybe two. So at the top of my list, I've got Hattie Hartman. So maybe if we can unmute Hattie and ask Hattie to ask her question, please. Are you able to do that, Richard?
Yes, I got it. Hello?
Hello, Hattie. Yes, we can hear you loud and clear. So thank you.
Wonderful. Very interesting to hear more about how this product is evolving. Has it already been applied? I'm wondering, and if so, could you mention a project or two? Mm-hmm. And the warranty period, what is that anticipated to be?
Yeah, so in terms of whether it's been applied, we've applied it for acoustic insulation in offices in London, because that's where we're based at the moment. Our production facility is going to start operation in the summer of 2021. And from that stage, we'll be able to supply about 10 to 20 homes per month worth of insulation. We've got a whole load of clients and organizations just awaiting the BBA accreditation to be completed, which we're currently in the last few steps. In terms of the longevity or the warranty of the product, we extend our responsibility beyond the sale. At the sale, a new responsibility starts, where at the end of the material's life, we collect it because that's a resource for us that we can feed right back into the production process. In comparison, like for like, any other insulation product on the market, after about 5 years, starts to deteriorate in value and performance. Our product has shown that it can last about 8 years before it shows those signs of deterioration. And that's because of the really high chitin content, which is like nature's plastic, basically. But it's completely biodegradable still. That's available in the mycelium.
Thank you.
Lovely. Thank you very much. Okay, we've got time for one last quick question from the audience. And so Harry Patikas is next on my list. So hi, Harry. So maybe we can unmute Harry and ask him to ask his question.
Hello, can you hear me?
Yes, we can, Harry. Thanks.
Hi.
Yeah.
Hi, Ahab. Thanks for that presentation. Really interesting. Yeah, I was really interested in the some of the performance characteristics of Biome, and in particular, how it might function in a retrofit context. So we're very interested in the interface with plaster and the use of it possibly as an internal wall insulation. So I'm quite interested in the capillarity, vapor permeability, hygroscophicity of the product. And I was wondering how that compares, for example, with wood fiber.
Yeah, so I've mentioned the chitin a minute ago, and that's something the mycelium naturally produces as it creates the material. Chitin is usually found in seashells and in exoskeleton of insects. It's like nature's fire retardant. It's like completely hydrophobic, so the water doesn't affect it at all. And the material that we create is not coated, so it remains breathable. So we've got a breathable material that is water permeable, but it also doesn't soak up the water, or it's not hydrophilic in a sense. So in terms of the water permeability, we've done, I think, 2 tests with BBA already on this, and we've passed both of them. We're awaiting one last final water permeability test. So the hydrophobic values of the material are really, really impressive. But in terms of the retrofitting, we're actually already in discussion with some councils around retrofitting projects. And the thing that sort of sets the mycelium apart is the way that the material is created. You can create the material to go into cavities in every nook and cranny in a building. So for retrofitting, you can create the shape that perfectly fits a stock of housing instead of generating a lot of waste trying to fit it to older building typologies. So it's got that kind of advantage as well.
Okay, thank you so much. Well done, Ehab. I think you did very well. There's a few more questions in the Q&A, so perhaps I can ask you to answer those, and we're now going to move on. So I'm going to hand over to Tom Ruddle from Egg Lighting. So welcome, Tom. So we've got 4 minutes of slides from you, and then onto the Q&A. So thanks for sharing your slides, and I'll put the clock on now. Thank you, Tom.
Okay, thank you very much, Simon. So I'm Tom. I'm a circular design engineer at Egg Lighting. So I'm responsible for developing Egg's remanufacture process. So Egg Lighting provide complete lighting systems as well as innovative control and sensor technology. And we really put circular economy very much at the heart of what we do. And we believe that it's possible to reduce not just energy use, but also material use through our products, at the same time as enhancing the spaces people use and helping businesses save money. So remanufacture isn't something that everyone is aware of. Remanufacture is not the same as reuse. It's not the same as refurbishment. Remanufacture is the process of taking a used product and restoring it to as new performance with a complete testing cycle and warranty guarantee to match. So in practice, what this means for us is we collect used lights, put them through a cleaning and disassembly process. And that means that we identify any imperfections or components which need to be replaced. And we always aim to replace the minimum number of components. We then go through and upgrade and reassemble lights. So that typically involves installing new LED components, particularly because this technology is improving year on year. And this means that we're able to keep about 90% of the material content of the light in use. So that includes a lot of metals, particularly aluminium, but also a lot of plastics, particularly acrylic and polycarbonate. And then finally, a really important step is complete testing cycle for every single light. And that means that we're able to guarantee the performance as well as environmental benefits of each light that we sell. And the LCA data that we've collected so far indicates something in the region of 6 kilograms CO2 equivalent per light and corresponding waste reductions. So as well as just shouting the environmental benefits, there's really quite tangible benefits for businesses. Obviously, commercial lighting is in every single office block, every factory that we all work in, every facility. And what we've identified so far is cost savings in the realm of 20 to 40% to the client, upfront savings, as compared to replacement with new lighting. And that's obviously because we're able to pass on the savings derived from waste reductions to the client. But it also means that we're upgrading lights to the very latest LED technology, and this can save a huge amount of energy bills day to day for businesses. So some indicative key performance indicators at the bottom left, where we saved a client £8,000 a year on their energy bills. As I've said, keeping the vast majority of material content in use. Remanufacture also fits very well with our lighting as a service business model and creates jobs, which is very important. So a final kind of summary of remanufacture as a process, particularly in lighting. What I really want to draw your attention to is this graph at the bottom. So this is what the UK lighting industry looks like. In 2019, over 42,000 tons of lights sold, only about 8% of which were collected in the WEEE directive. So that means really proper collection and treatment. So we've looked at this and we believe that remanufacture is the appropriate solution for that. It's a joined up long-term solution that addresses purchasing decisions, leads to better product design, and we believe this should be carried out in a collaborative approach. So I'll wrap up there. Thank you very much.
Excellent, excellent. Thank you, Tom. Excellent presentation. So over to our judges. So I'm going to start back with you, Julie. So I'm wondering if perhaps if you can ask a question of Tom.
Yes, thank you. Thanks a lot for this. Can you start with any type of light? And when you say 30% improvement, is that on average from what you've seen around what you collect? I mean, presumably if you're collecting LEDs, you don't get these sorts of improvements.
Yeah, so the simple answer is no. We can't do the same process for every single light. There's a number of factors that affect how effective remanufacture is, and that depends on the sector of the light fitting. But so there are technical factors, but there's also logistical factors. But overall, we believe it is a process which is suitable for the majority of lighting. With regard to the 30% improvement in performance, there's getting into the nerdy stuff. You might have all heard of Moore's Law, which is the rapid improvement in computing technology. Well, there's actually a equivalent for lighting. So LED performance is improving year on year, really quite staggering improvements. And at the same time, the cost of production is reducing. So everyone is aware that it's imperative to move from fluorescent lighting technology to LED, with huge energy savings derived from that. But that 30% example is from a real world example where we upgraded our clients' lights at the end of their warranty period after just 5 years to the latest LEDs and saved them 30% on their energy bills.
Excellent. Thank you, Tom. Nice answer. So Mark or Neil, have you got any burning questions?
It looks quite labor intensive, so I was just wondering what the scalability is of your processes.
Yeah, absolutely. It is definitely, it's not really an automatable process, I don't believe, to a complete extent. Personally, I wouldn't say that's a bad thing, particularly in the context of unemployment at the moment. And we've already got 19,000 jobs in the remanufacture sector in Scotland, 192,000 across Europe. So to an extent, I see that as a benefit. In terms of scalability, the way that we see this is we don't really want to have ownership of this. We want there to be a trusted, reputable remanufacture end-of-life option available to businesses across the UK and Europe, in the way that there is currently an ecosystem of recycling operatives. However, recycling subtracts value from lights. Lights go through a shredder. metals and plastics are separated out, downcycled, and clients are faced with cost. So we believe that remanufacture is a value additive process, and this incentivizes more environmentally beneficial behavior.
Okay.
Thank you.
Excellent. Thank you both. Thank you, Tom. Okay, audience, so it's over to you now. So for those who've just arrived, we've got an opportunity to ask your question to our contenders. So pop them into the Q&A, and whichever one is upvoted the most, we'll ask that question first. There's been a battle, but I'm gonna ask Hattie Hartman to. Hattie, you've managed to ask 2 questions, which are, given the time constraints, I think perhaps if you could just pick out one question and ask that. So Tom, please.
Yep. Hello, Tom. Very interesting. Where do you source your lighting from? Are you mining demolition sites, or is it sort of one project at a time?
Yeah, really, really good question. So firstly, this isn't a process that we're kind of at high volumes yet. It's in early stages, and we're actually conducting an Innovate UK project at the moment. At the moment, lights are being sourced from a variety of sources. The easiest is actually just through our existing clients. So we've got, quite a backlog of clients that we've worked with over the last decade or so. Demolition sites is a very difficult one, but we really hope that's something that can develop in the future. The other one to mention is, I mentioned very briefly about the business model, lighting as a service, which people may have heard of. I'm not going to go into that in any detail, but we see that as a procurement route for use lights to be remanufactured in a consistent manner.
Thank you.
Excellent. Okay, thank you. So we've got time, I think, for one more question from the audience. I'll read it out because it's anonymous. So it says, you mentioned a collaborative approach. What opportunities are there for other businesses / partners to get involved?
Fantastic. So I would firstly just encourage the questioner to visit our website, because we've just published a white paper which outlines really our thinking on the matter. What we envisage is an open data sharing system where technical information for every light is openly available to approved remanufacturing operatives. And I don't think that it would be for us to be regulating what another remanufacturing operative is doing. However, we are working with the British Standards Institute, the remanufacture subcommittee, to develop a standard for remanufacture of lighting equipment. So we really do genuinely believe that this should be something which can be picked up by circular organizations around the country.
Brilliant. Okay, lovely job. I've got time for one last question. I'm just going to read it out. So this is from Brian Murphy, Brian Speckman. So is your service only for your own product, or are you looking for other compliant products? Does that say Zahaga? I don't know what that is. Perhaps you can tell me.
Yeah, definitely. So if we see a Zaga compliant component, that's definitely easy for us, because we know we can purchase the upgrade LED components very simply. Again, it is easiest for us to remanufacture our own lights simply because we know everything about them, we know what's in them, and we can do that very straightforward. But again, whatever we can do, we will tackle. And again, just to recall that image of under 10% of lighting equipment being recycled, even recycled per year, we really are looking for as much environmental impact as we possibly can through our remanufacture process.
Excellent. Thank you very much, Tom. Okay, audience, so keep your questions coming in. Keep your questions coming into Ehab. He's online. He's going to be answering any questions that come in. And keep your questions coming in to Tom. So we're going to ask Tom to keep an eye on the Q&A and respond to any questions that come in there. So we're going to move on without further ado. So I'd like to welcome Amir Gross from Treetop Biopack. Thanks, Amir, and over to you.
Hello, everyone. Good afternoon, and thank you for having me.
Pleasure.
Amir Gross from Treetop Biopack. We specialize in compostable packaging solutions. I'm a packaging professional, been in this industry for about 15 years. And in the last 4 years, been focused on sustainable packaging and alternatives to plastic. I've been in plastic for most of the career, but then realized we do need to do something different and develop new sustainable solutions. If you can go to the next slide. So Treetop, we developed a range of compostable packaging solutions to replace and give an alternative to some of the most common plastic packaging applications. These materials are used, by almost every company that manufactures anything. If you think of stretch film used to pack pallets and to pack products, adhesive tape, everybody uses adhesive tape. Shrink wrap used over here. We have a sample from insulation, but also a very common plastic material to be used. And bags, people that manufacture products, a lot of product coming bags, small, big, and there's a very high usage of plastic. So it's used in a very high volume by almost every company. The materials have very similar properties, very similar look and feel to conventional plastic. They can be used on similar machines. They don't disrupt production, and they give the same solution. What happens to these materials once they are used? They compost, they break down, they don't leave any microplastic or pollutants behind. These materials are really very new, very innovative, because they're just new. It's just been developed in the last 2-3 years, some of them in the last 12 months. So it's all very new materials that can replace common plastic. We can go to the next slide. And how this can help. So packaging, according to estimate that we got from a few sources, that the construction industry in the UK generates about 50,000 tons of plastic packaging waste. So a lot of plastic packaging being generated by the industry, and really something that, speaking to a lot of people in the industry in the past few months, I realized how much the industry is concerned about this and about plastic, and how compostable solves the problem of plastic. So the way we work today with plastic, with packaging, is kind of what's called a linear economy. So you have packaging, after you unpack the product, you need to get rid of the packaging. Most of it goes to landfill and to incineration. Globally, about 9% of plastic does get recycled. In construction industry, according to some statistics, it's actually 2 to 4% that get recycled. And this material that gets recycled just eventually will go back to the environment when the recycled product will end its life. Compostable solution gives more of a circular economy solution to that, to packaging. You start from a plant, because these materials are made not 100%, but has a very high percentage of bio-based material. So you start from a plant, you make packaging. After you unpack, you compost it, and that turns into compost, and you use to grow more plants. So a full circular solution for packaging that will really reduce the plastic waste and the plastic footprint of the industry. Next slide, maybe.
The 4 minutes is up, Amir, so if you can bring it to a close.
All right, sorry. So why these materials innovative and why we think of their benefit. So First of all, the meeting the plastic challenge and replacing plastic. They give a solution for a wide range of applications. They are suitable and can be applied by a lot of companies in the industry. And also, it's very easy to communicate the benefits to the public and to government, to customers, the benefit of the plastic. If you replace the stretch film around pallets, you say, okay, we saved 20 tons of plastic from the environment. So yeah, that's the
excellent. Thank you. I'm sorry to rush you, but that's nicely done. Thank you. So over to our judges. So I think Neil, I think it's your turn to ask a question. So perhaps if I can ask you to unmute and thank you.
Great, thanks very much, Amir. Great to hear a bit more about that. I know we've chatted briefly before about it. Are you able to say something very quickly about how you manufacture the product? What are the raw materials that you use to create them, and what's the process for that?
Yeah, the raw materials, I won't bore you with names of resins, but basically it's a fossil-based compostable resins, PBAT, if someone knows. So this is one of the main material. The other one is PLA. PLA is a product it's a resin that derives from bio-based. So it's derived from sugar, from corn usually. It's derived from the waste of that industry. So if you produce sugar from the leftover materials, you can generate, derive resins, and these are the main raw materials.
Excellent.
Great, thanks very much.
All right, thank you very much both. So perhaps round to you, Julie, now. So please.
The fact that it's compostable doesn't mean it would be composted. So have you done market research with who would actually use it to know what happens to the packaging? Because it's actually quite certainly in consumer products, it's a problem. People don't know it's compostable, or they just don't compost it, and it actually ends up composting in landfill, which is even worse and produces methane and all that. So how do you know how many people use it on construction sites?
So yeah, so first of all, there are companies who would collect and compost these materials. There are, just like there's composting for green waste and organic waste in the UK, in every country, these materials will eventually join that organic stream. By the way, if it breaks down in a landfill, it would not generate methane because it's a different type of composting. It composts with different bacteria. It doesn't generate methane, but it does need to be collected. These materials, like any, like plastic, doesn't get recycled. It doesn't get recycled. So the same with compostable materials. They do need to be sent to the right place to compost, and also to get the benefit of it, because you got a compostable material, you got compost, and that's a benefit. That's a resource that we need more of. So it's a benefit, and it should go into a composting.
Okay, thanks. Mark, you've got time for a quick fire one if you've got something.
Yeah, I was just wondering whether it's possible to either reuse or recycle the materials. So you see the composting as an ultimate end of life, but maybe you can reuse or recycle in between.
I guess you reuse them. I mean, the material that we're talking about are flexible packaging, and flexible packaging is always a difficult one to reuse. If you made a very robust bag of compostable packaging and you manage to collect it, I guess you can reuse it. They do lose durability after a while. They are kind of built to break, but you could reuse it. There are also technologies that are being developed to recycle compostable materials, but the main benefit is really if you compost it after you used it, it returns safely to nature, and you don't need to worry of contamination and pollution.
Okay, thank you very much. All right, audience. So I know you're there, although I can't see you. I do know that you're there. this is your opportunity to ask any of our pitchers some grueling questions. So please put them in the Q&A. So at the moment, I've just got one question in the Q&A, which is Brian Murphy. So perhaps I'll ask Richard to unmute Brian this time around, and I won't fall over his questions and wonder what he's talking about. So he can ask his own question. So Brian, over to you. Yeah, hi Brian.
Hi, okay. Yeah, so I wanted to know, because I missed part of your presentation. In Peterborough City Council, they collect all the biodegradable waste and they give us biodegradable bags. What they do, I'm told, is that they take all of the biodegradable waste out of the biodegradable bags and put them into composting and put the separate bags into a different process, which to me sounds like it's bonkers. You know, it's a labor-intensive process to get all those bags out of the process. Do you have similar problems with your material? Do you have to take them out to a separate process?
Yes, what they're doing, they're separating the organic waste to anaerobic digestion, which generates energy. And compostable materials, compostable packaging usually it always requires aerobic digestion, which is a different type of composting process.
Yeah.
It's not a very labor-intensive process because it's all done with machines on the lines over there. But in theory, the packaging with the organic waste can all go into one pile of aerobic digestion and break down in there.
Okay, thank you.
Thanks, Brian.
Cheers.
Okay, so well, there are no more questions at the moment in the Q&A. I think at this stage we'll move on. But if you do have any more questions for any of the contenders, any of the pitchers, then just please put them in the Q&A, and we've asked everybody to keep an eye on that and respond as they go through. So big thank you to Amir. So I'd now like to welcome Aaron from Solus, and over to you, sir.
Hi guys, hope you're all well. Like I said, I'm Aaron from Solus. I look after the engineered hard flooring, biopolyurethane and cork sector in the business. We've been going for 25 years. As the business is moving on, we've recognised that the need for sustainability in our sector is just missed. So we've been going for about 2.5 years now. We've got 80 staff. We've got sales managers placed throughout the whole of the UK. Our market is predominantly in specification, both residential and commercial. We strive to place responsibly sourced and manufactured products on every project that we work on. As salesmen, it is probably the most difficult task, as you all know, the first thing people want to talk about is price. We're currently being audited for FSC and PEFC accreditation to go along with that. And the products from our ranges are tiles, engineered wood, cork and organic flooring. If we can move on. Cheers. Okay, so the main product we wanted to talk about that we did last time was the organic flooring. It's an organic polyurethane that's made just from chalk, castor oil and canola oil. So there's no petrochemicals contained in the product itself. It provides an environmentally friendly, high-performance floor covering that can be used in residential to commercial installations. It has about 120 different designs in it, both stone and wood plank. So for any classification or use, it's perfect. It gets graded 0 on VOC, so there's no harmful emissions coming out of the product. It gets class 43, which is for industrial use and commercial. It carries a cradle silver certification. It's UV resistant and temperature stable. Indentation recovery is perfect because it's not a plastic product. It can actually recover after having products hit on it or left on top like tables. It has a low life cycle cost. So this is our biggest problem when selling the product, is initially it does cost more. We're not going to pretend it doesn't. But over the life cycle of the product, because it will last longer than the plastic equivalents, and the maintenance of it is a lot less, you'll save money in the long term. It has usage of renewable raw materials and natural fillers. Okay, this was our biggest question. We spent a lot of time with Accord talking about this for their project. When is plastic not a plastic? Everyone on here is trying to find a viable alternative for plastic products in construction and everyday life. Unfortunately, what we found is that within the flooring industry, no one's really taken note of this, and the fastest growing sector is unfortunately vinyl flooring, predominantly luxury vinyl tiles, also known as LVT. With organic flooring, we're attempting to reverse this trend. The molecular structure itself of organic flooring is that of such that it replicates the building blocks of plastic. However, organic flooring contains none of the harmful chemicals we're seeking to eradicate. It also has uncritical disposal, and it has a climate neutral production. So, question to you guys is, should it be defined as a plastic? Last slide. Okay, unlike other people, we actually care. As salespeople, our job depends on making as much as we can. And naturally, most people gravitate towards the thing that they can easiest sell, and usually it's the cheapest. This is definitely not the easiest sale we've come across. We spent a great deal of time looking into other products that also offer viable alternatives to vinyl flooring. They're looked upon favourably by the market, such as linoleum. During this process, we've learned, like organic flooring, its molecular structure also defines it as a plastic, but to everyone else out there, it's not defined as one. Therefore, we hope and believe that organic flooring should be treated in the same way. The product itself has been in production for 10 years, and the factory and the chemists there are still trying to improve it day in, day out. As technology advances, they hope to do better and eventually achieve perfect utopia. And we're looking really for, the thing that I always struggle with is plastic is a fantastic product, but like we like to use, it's killing the planet. And we're trying to find a product, and we think we found it, that can do what a plastic does, but with none of the drawbacks. As we delve deeper into the product, we've become more determined to succeed at our goal. And we really need the help of people like yourselves to educate the market. We appreciate the opportunity you guys have given us today, and we hope that you feel the same way. Thank you very much.
Excellent. Thank you, Aaron. That's really, really good.
No.
Okay, judges. So I think I've slightly lost track where I am, but I think I'm going to start with you, Neil, to ask the next question. And I'll come back to Julie and Mark. So perhaps if I can ask you to ask a question.
Yeah, thanks very much. That was a really interesting presentation. You mentioned that you thought it was a hard sell. I don't know if that was because you were talking about the kind of end cost of the product in terms of purchasing. Where on a sort of scale of sort of 0 being the sort of bottom end, 100 being the top end of the market, where would you kind of position this product in terms of its retail cost?
I would stick it. It's probably, we would look at sort of the 60-70% in all honesty for where you would sit at. If you compared it to what we come across most household names like Antico and Karndean, you would sort of stick at that sort of level.
Okay, great. Thanks very much.
Okay, thank you. And over to you, Julie.
Thank you, Aaron. You said it had an uncritical disposal. What do you mean by this? What happens at disposal?
Okay, Paul is actually the man that loves this question.
The thing with this is that the people that manufacture this are from Germany. And what they are classing as uncritical is that if you put it in a landfill, it will eventually, it'll decompose, it won't remain in its form forever, but it does take a while. The way they would like for it to be disposed of is to burn it, because it can be used to generate power and heat, and it doesn't emit anything whenever it's burnt. So it's not, whenever we had the last discussion, it was, can it be recycled? Yes, it can. But the problem in the current world is, where does it go to be recycled? How much does it cost to get it to where it can be recycled? And how long does it take? And what's the carbon footprint of doing all that? And that's basically what the manufacturer wants to try when we say utopia, is we want a product that performs to the level that's expected, but whenever it's no longer required, it can be disposed of in a way that's both economical and environmentally friendly. So it's not critical that you have to take it somewhere like asbestos or even like vinyl. What do you do with it? You put it in landfill and it's there forever. So it's to try and get to where we want to be. It's not really critical that it has to go back to a recycling plant, but it's not perfect yet. If that helps to try and explain it, but it's not easy.
I think it does.
Yeah.
Thanks, guys. Okay, Mark, have you got a quick fire question?
Well, I'm a chemist, so I'll just answer the question you posed. Yes, it is a plastic. It's polyurethane, and certainly taking your presentation at face value, it would appear to be a very pure form of polyurethane, because you haven't got the contamination from petrochemicals.
Yeah.
And I think if I was to give you some marketing advice, you may run into difficulties in the future trying to market this product as something that isn't a plastic when it is. And I think what you need to do is really focus on the transparency angle of it. And if you look at the 6 pillars of the ASBP, transparency is one of them. And there is a place for plastics, and you know, we can't have a zero plastics construction.
No.
Any notion of that is unrealistic. So it's just food for thought, really. I think, you know, that it looks like a good product.
We know that is our biggest stumbling block, because some companies actually promote it as vinyl-free vinyl, which is a contradiction of itself. But what we're trying to is that people will say linoleum is a healthy product, and they use it in hospitals and they use it everywhere. And it's perceived as being a natural product because it's made from basically the same products as us. But the consumption of electricity to make linoleum is much higher than it is to make our product. But because our product looks like vinyl, it's automatically just, this is vinyl because it looks like vinyl.
Yeah.
And that's why we think we need people like you to educate the people that are between us and you that specify the products. I mean, we can get some architects to agree to do it because they understand the benefits of the product, but then we don't get laid on the floor, because by the time it gets to a flooring contractor and a builder, all they're interested in is the price.
I mean, if you look at what the ASBP stands for, is products that are demonstrably sustainable, evidence-based. So, you know, I think there's probably a lot of hidden plastics in construction.
Yes.
And over the passage of time, you know, that'll become more and more evident. So the more transparent you can be and upfront about what your product is, I think the more it'll stand you instead for the long term.
Well, it's becoming more and more successful in America because government buildings are being banned from using vinyl on the floors. So hopefully it makes its way across the Atlantic.
Okay, excellent. Thank you, guys. I've got one eye on my timer. So I've got quite a few questions here in the Q&A. So I've got Brian Murphy has asked 2 questions. So Brian, perhaps I can ask you to maybe select one of the questions there, and we've got a few in there. So over to you, Brian. Are you there, Brian?
Unmute. Can you hear me?
We can, yeah, there we go.
Okay, sorry. Okay.
No worries.
Solus, the multi-layer product is a complication to recycle, I'm assuming, and C2C suggests avoiding those kinds of complications. So I guess that C2C like the bio-based ingredient, but have ignored the complications of the kind of multi-layer process. And I don't know enough about this to have a strong opinion, but polyurethane is a complicated process. And is it a good thing to turn natural materials into polyurethane? And then what happens to it at the end of its life? And I'm not going to get the second question in, so I won't be able to follow that up.
So what are we supposed to answer? The answer is everything you say is correct, but we have hospitals, schools, factories, offices, retail shops, and people's houses where they all have to walk on a floor. Right? And not everyone can have carpet or cork or wood. So they have to have something which doesn't grow bacteria in a hospital, doesn't have VOCs in a hospital, but it has to last for 15, 20 years. So what's the alternative? So what we're proposing is we've got a product that meets all the requirements of the modern world, but with as few of the detrimental effects as possible.
Okay, thank you so much, everybody. That was quite a grilling for you two, so well done. I think you responded very well.
We're used to it.
Okay, there's a couple of questions that we haven't had time to get to in the Q&A. So Aaron, maybe I can ask you to have a look at those and respond to those. Thank you very, very much for that. So we're going to move on now to John Thorogood from Grafenstone. So John, if I can ask you to unmute, and over to you. Thank you.
Thanks, Simon. Good afternoon, Dragons, and also a warm welcome to the wider audience. My name is John Thorogood, Head of Sales for Grafenstone UK. Grafenstone represents the best of tradition, innovation and modern technology, and has become one of the world's most ecologically certified paint brands. We have achieved 18 international certifications and conform to all of the broad range environmental assessment organisations such as WELL, LEED, BREEAM and Cradle to Cradle. We use only natural and sustainable ingredients and in all of our paints, such as lime and mixed minerals. And these are infused with a material called graphene, which won the Nobel Prize for Physics in 2010. This wonder material brings numerous qualities to our paints, including durability, flexibility, longevity, and homogeneity, elevating them from the soft, brittle mineral paints of the past to a range that can really compete with modern plastic paints, offering a viable alternative without compromise. Next slide, please. Here is a quick overview of our main product range. First, we have Ambient Pro Plus, a natural photocatalytic paint with graphene technology, our air purification paint. This paint actively and continuously neutralizes and decomposes airborne contaminants such as nitrous oxides, sulfur oxides, and other VOCs, cleaning the air in our spaces and the wider environment. Another huge positive of this paint is that being made mostly of lime, it will absorb up to 4.8 kilos of carbon dioxide during the curing process. It is also fire rated to Class O and Euro Class A standards. It is VOC free, MIT free, plastic free, naturally antibacterial and highly washable. Next, we have our full line paints, Ecosphere and Biosphere, similar qualities to the Ambient Pro Plus but without the photocatalytic effect. These paints are perfect for those with a focus on carbon capture and reducing their impact on the environment. Ecosphere can absorb up to 4.9 kilos of carbon dioxide per 15 litre, and Biosphere an even more impressive 5.5 kilos. And lastly, we have GraphClean, our ecological durable mineral matte emulsion. It is available in over 1,000 colours and offers clients a fully natural, sustainable and healthy paint option with even higher durability, making it ideal for the needs of demanding environments where colour may also be a high priority. It is VOC free, MIT free, plastic free, fire rated to Class O and has a solid content of 70%, giving it unrivaled opacity. Next slide, please. Grafenstone's core values are ecology, nature, sustainability and respect for the environment. Our factory is powered by 100% renewable energy and we use non-polluting raw materials and recycled wastewater. Our products meet the principles of a circular economy and our paints absorb carbon dioxide whilst curing, cleaning the air that we breathe, and we have reduced carbon dioxide emissions by 428 tonnes by selling 1,800 tonnes of paint. Our paint containers are made from 100% recycled plastic and are also 100% recyclable. We reduce the water content in our paints to reduce the weight. This reduces the carbon impact during transportation. So no stone is left unturned at Grafenstone, and we are constantly looking to improve our already exceptionally high standards. Our paints are all plastic free, with no acrylics and no toxicity, and conform to the principles of circular economy. In contrast, most modern acrylic or plastic paints will eventually break down and become microplastics, polluting the land and our oceans. And when you consider that nearly 10 billion gallons of paint are sold globally each year, with the majority of that being acrylic or plastic, the long-term negative effects of this are quite frankly disastrous, and something people that just don't consider. Next slide, please. Graphenstone paints are healthy, natural and durable, offering the perfect solution for a world that is changing fast. We are the first generation to fully understand and realise the impact that our actions have, and the only generation that can make the necessary changes to turn this around. And reducing and eliminating plastic where possible, especially in larger consumption areas such as construction, is a vital change that needs to happen, contributing massively to our collective goal of a more sustainable and healthy planet to live in. The problem has always been attitude and perception. For too long, going eco, healthy or plastic free has been seen as a cost addition rather than a value enhancement. We know well no longer is that the case. Graphenstone offer a viable alternative to plastic paints, while also achieving the highest global standards for sustainability, health and well-being and ecology, while still offering tough, durable finishes at competitive prices. Thanks very much for listening. I'll take your questions.
Thanks, John. Very good. Thank you very much indeed. So audience, keep your questions coming in for all of our contestants this afternoon. So thank you for those. So Julie, I'm going to ask you first to come on and ask John a question, if I may, please.
Thank you. Yes. John, when you say that I think it's the Ambient Pro Plus product, it eliminates pollutants like NOx, SOx, VOCs. What are the byproducts? How long is the effect for? How much paint do you need to have some sort of discernible effect? But I'm particularly interested in the byproducts, because some of these products that claim to remove pollutant actually create byproducts that are worse than the original one. So.
Yeah, hi Julie, that's a great question. I think there's still a decent level of testing going on with these types of technologies, with photocatalysts. The sort of the component that we use is a form of titanium oxide, which basically, once it's in contact with UV light, it will produce this decontaminant effect. Essentially, it's a continuous effect, and it will last as long as the paint is clean. So as long as you've got an effective clean surface, it will continue to do that. The byproduct is a dust, essentially. I would assume some of it's turned into some sort of a nitrate dust of some sort. So I have had a conversation before about the dangers of potentially that going into waterways. We have looked into it, and there's no significant risk that we're aware of. But as I say, this sort of technology is being utilised for a massively positive reason, and reducing a pretty much a larger problem, in my opinion. So it is a very good question, and we are certainly currently undergoing our own testing as well, just to sort of expand on the knowledge that we can have from this side of things. But certainly, no doubt, the starting point is for an excellent reason to try and help reduce pollution and VOCs.
Thank you.
Thank you.
Okay, thank you very much. All right, Neil, so over to you, if I can ask you to ask a question of John.
Yeah, thanks. Yeah, thanks, John. I've got two questions, actually. One is the same one that I asked Aaron. I was just to ask what sort of, because it's a retail product, what sort of level are you pitched at? Are you sort of lower end, or are you kind of Farrow and Ball and so forth? So what level of the market are you pitching? And the second one is, and this is maybe a complete daft laddie question, because I know nothing about paint manufacturing, but are you restricted in terms of the colors or the finishings that you can have because of trying to maintain your eco credentials? So for example, silk, gloss, matte, etc. Are these things which you are restricted, as I say, when trying to keep your product and it's sort of
yeah,
ecological?
Two excellent questions, Neil. The price is an easy one to answer. We're certainly not the cheapest on the market, but we're by no means up the top end of the expensive market either. We would we pitch ourselves probably halfway between a good trade paint and a designer paint. So you've used the example of Farrow and Ball. We're sort of in that sort of gap between those two paint markets. So we kind of sit on our own, which is quite unusual, actually. So I guess it depends what you're being compared against to be whether you would see it as an expensive product or a good value product. When you compare it to like-for-like products, we are pretty much the least expensive available on the market in the UK, which is an encouraging position to be in. And when you factor in some of the extra USPs like the incredible durability of the finish, it really does single us out against some of our competition. The second question probably would take a lot more time to answer fully, but the short answer is there are some limitations of what types of paint we can produce because of the materials we use. So most of it that we use is natural minerals and limes. Lime being incredibly white can limit colour choice. So in certain paints will be pastel colours only, but we do change our products slightly, which are all still covered under cradle to cradle certifications to allow up to 1,000 colours internally and 322, I believe, externally. So the other limitation that's worth mentioning would be high sheen products that you mentioned, for example, gloss. We couldn't make a gloss in our product because you'd end up adding acrylic resins to do that. So we're actually engineering a 40% sheen level product at the moment, which will probably be the highest we could ever go. But it's about using the right materials, sourced sustainably and responsibly. There will always be restrictions on how far we can go. But I will reiterate the point that we've got a viable alternative to pretty much everything on the market, which will compete with the modern demands of what people are asking for at a similar price as well, which I think is key.
Okay.
Brilliant. Thanks very much.
Thanks, guys. Mark, have you got a quick fire question?
Yeah, just one. I've used this paint, by the way. I think it's fantastic. But when I was washing my paintbrushes, it did occur to me, what's the fate of the graphene that I'm washing down the sinkhole?
Yeah, there's always questions asked around graphene. It's kind of this wonder material that's sitting on the lab desks everywhere, and people are trying to sort of decide how best to use it. And there are many forms of graphene, and there has been some risks highlighted in certain areas, and it's all to do with the actual construction of the graphene fiber. We use a pretty basic form of graphene fiber because we need it to do a pretty mundane task with our product, and it is to basically bind the minerals together, and that holds all the paint and gives it its homogeneity and its strength. That is a very unharmful form of graphene. It's a natural element. It is essentially just carbon atoms, which are abundant in everything that is around us. So that would go through the normal waterway cleaning system, I would have thought, and not cause any particular harm. If it was entering into drinking water systems or through ingestion, that sort of thing, because of the makeup, it's a simple form of graphene. The ones that cause the problem are sort of have a fishbone kind of construction to them, which then can become a problem for ingestion and also inhalation. We've made sure that we don't use that sort of thing because our paints at some point will be abraded, for example, and can create a dust. So the safety question around graphene is an important one to bring up and to discuss. But at this stage, in what we've done, we've had no sort of negative problems to report. The product is very safe. But it's a very good question. But it would be cleaned in a normal way that you would clean your normal brushes. But what's going down your wastewater is a much more natural, healthy, sustainable product rather than petrochemicals and acrylic paints.
I bet. Lovely. Okay, thank you so much. We've got a couple of questions in the Q&A, but I need to move on because we're running short of time. So John, if I can ask you to respond to those questions. Absolutely. And then I'm now going to introduce Dominic Putman and Simon Ayres from Warm Shell. So if I can ask you to unmute, Dominic, and I'm going to put the timer on, and I'll hand over to you.
Could you bring up the first slide, please, Simon? First of all, I should say hello to everyone. Thank you for inviting us to pitch. My name is Dominic Putman. I look after Head Marketing and Business Development at Lime Green Products, the leading manufacturer of lime mortar plasters and renders, and Warm Shell. Warm Shell is a natural and breathable insulation system for walls and roofs made up of 4 elements. Firstly, wood fibre boards made of waste shavings from timber grown in FSC certified and sustainable European forests. Secondly, non-toxic, very durable lime renders and plasters. These lightweight aggregates are made from the waste residues of the glass recycling process blended with natural hydraulic lime. Thirdly, glass fibre reinforced mesh, and finally, lime or water glass based mineral render. So what does it offer? It's suitable for both external and internal retrofit projects and timber frame constructions. It provides outstanding energy efficiency, comfortable living throughout the year thanks to the phase shift properties of wood, meets passive house principles, outstanding acoustic insulation and breathable walls to prevent condensation and damp without any chemicals or additives. And how does it perform technically? The external system for masonry has been tested to ETAG 004 standard, and warm shell wood fibre meets EN 13501 and A1 fire performance classifications. The system's carbonisation properties limit the speed at which fire can spread. How does warm shell help to reduce plastic in timber frame homes? Very warm new houses can be built using just wood, metal fixings and lime. As you can see in this diagram, a typical construction contains very little plastic and is very easy to recycle. Internal lime plaster on plasterboard or wood fibre board, OSB taped for air tightness, the timber frame, natural fibre stud insulation, and finally external wood fibre board with lime render. Conventional UK timber frame homes currently have a cavity with high embodied energy fire barriers and are entirely wrapped in a plastic breather membrane. In 2019, 60,000 new timber frame homes were built in England and Wales, which are almost 25% of all new homes. These required 7.2 million square metres of non-biodegradable polyethylene membrane, with a carbon footprint of almost 7,000 tonnes. Warm shell doesn't have any of these components. Lime renders or plasters don't contain modified polymers or require plastic silicone paints over the top. Incredibly, using warm shell wood fibre insulation would reduce the use of plastic-based insulations by almost 35,000 tonnes for these 60,000 timber frame homes. This is compared to a PIR insulation. Next slide, please. So what are warm shell's low carbon credentials? For the 60,000 timber frame homes require 1,200,000 cubic metres of insulation. The manufacturing process of warm shell wood fibre, as opposed to PIR, would reduce carbon emissions by 67,200 tonnes. Wood fibre insulation will store 250,000 tonnes of carbon dioxide over its lifetime. That means a net gain of 318,000 tonnes less carbon compared to a PIR situation, plus a further 7,000 tonnes by eliminating the polyethylene membrane. And of course, all our system components are fully recyclable, so that should be added to this equation. Finally, warm shell should also win this pitch because if the UK government commits to sustainable building construction, as has happened in France, Lime Green has 80% spare manufacturing capacity for the lime render and plaster components. We will also be able to easily scale up our existing operation to meet additional demand. We also expect additional wood fibre manufacturing capacity to be available from next year or latest 2023. Thank you for listening.
Great, thank you, Dominic. Really exciting bit of news at the end there. Without further ado, over to our judges. So I've lost track where I've got to, but Julie, I think I'm going to ask you to unmute and ask Dominic a question, please.
Yes, thank you. Do you already have examples of projects where this has been used and any monitoring?
Yes, we have used, the warm shell systems have been installed for the last 10 or 11 years in different locations in the United Kingdom. The only one where we have had monitoring, which is supported by SPAB and more recently by English Heritage, is on a terraced house in Shropshire. That was essentially assisted by the installation of internal wall insulation, but in this particular case, this was a brick-built, typical terraced home, as opposed to timber frame, which obviously I just focused on for the presentation. But we have, I don't know the exact number, maybe my colleague Simon might be able to enlighten us, but I know we have certainly supplied material to many hundreds of projects around the UK over the last 10 years.
Thank you.
Okay, Neil, over to you.
Many thanks, Dominic. Just a question on performance in sort of how does your product perform in relation to, say, a sort of conventionally made insulation product of the same dimensions? Does it require it to be thicker or what have you? How does it compare?
Maybe I could ask Simon to chip in on that one, if you don't mind. Simon?
Yeah, thank you, Dominic. It depends by how you mean by perform. Do you mean perform thermally or heat protection?
Sorry, yeah, I was thinking.
Moisture?
I was thinking U values to be specific. Yeah.
So if you're just looking for U values, it's not the most thermally efficient. But if you're looking in as a product as a whole, in terms of acoustics, thermal, heat protection, moisture management, these things, then it performs better. So it depends. If you're just focusing on thermal performance, it's not as good as others. But if you look at it as a whole, then it's better.
Yeah, which are all arguably equally important, actually.
Yes.
Thanks for that.
Yeah.
Okay, thank you. And so, Mark, over to you for one final last question.
I'm just going to help Simon out with that answer as well. Thermally, it is just as good. You just need a different thickness to achieve the same.
Well, yes.
That's a good answer, Mark.
Yeah,
I like that.
You should read the multiple rules of insulation briefing note on the Natural Fibre Insulation Group website. But how does it? What's the time difference for construction on a sort of like-for-like property for the warm shell system versus something that's seen as more conventional?
Well, if you compare to the timber frame's a good example because it's they're almost half. It depends how you construct a timber frame now, but if you can compare it with some methods of construction now, and there's half the number of components, less than half the number of components, and so it's simpler and therefore quicker. It's easier to get right, which is important. If you've got somewhere between 12 and 18 components in a timber frame construction, ignoring all the different fixings and that sort of thing, we're just talking about the sort of main elements, then it's easier to build it correctly. There's no cavity in the wall. It's a solid wall, and there's only about 6 main components if we ignore the render beads and that sort of thing. So it's not very many. So I think it's quicker, but I haven't, in all honesty, done a time and motion study on it. But
that's an interesting point, because one of the reasons why wood fibre board insulation is so big in Germany, for instance, is that the timber frame industry learned how to build quicker, more efficiently and more cost effectively with it. So that you got a good point there.
Yeah, I would say that it is designed, the components are designed for carpenters. They're designed to fit. The dimensions work well with timber framing methods. The tongue and groove aspect of the boards allows you to not have to join it on. There's less waste. If you take a normal sheet of rigid PUR board, if you cut that up to go between your rafters or your joists, you always end up with a skip full of waste, because all the offcuts, the board doesn't divide into the stud spacing correctly. Whereas with these products, there is less waste because it's designed for the job in the first place.
Okay, excellent. Thank you so much, everybody. So there's a few questions from Brian Murphy in the Q&A, but we've run out of time. So perhaps I can ask Simon and Dominic to respond to those questions whilst Catherine is speaking. And then the judges, you've got a little bit of time now to have a quick think. People in the audience, same for yourself. Come to the conclusion who you think should be the worthy winner, which is a very difficult decision. I'm glad I'm not having to make it. So over to you, Catherine. Thank you.
Hi everyone. I'm going to fly through these because we've only got 5 minutes and everyone wants to know who's won. But just a very quick introduction to the Plastics in Construction Group. This is where the Innovation Pitch Series has come from. We're about 2 years old now. Different members interested in different things. Obviously substitutes for plastics. That's why we're here today. A bit more on single-use plastics as well from some of the contractors. We're a collaborative stakeholder group. You can see from the bullet points some of the things that we're doing. It's very much learning, cross supply chain, looking at challenges and how we can address them in a practical way, and also connect with others. So we realise that in some areas of plastics it's a busy space. So where we can add value, we will try and do that. This is an example of some of our plastic members and what they're up to. So we have people doing campaigns on site related to single-use plastic, community events. We have the Interreg Charm project, which is building 12 virtually plastic-free houses. They're actually being constructed at the moment, and we will work with them to disseminate a lot of the knowledge there in terms of what they have substituted and how they've found that. Some of our members, and you've heard from one at least today, have products that aren't plastic or very low plastic. So that's copper, organic flooring, timber windows, aluminium guttering, to give you an idea of them. So what we're doing, we have a few outputs now, and we're building on our outputs. So I'm going to whiz through. We have a stakeholders map, which you're free to use. Just go on our website. It's quite a clever little piece of software, which everything links up. So the stakeholders link up to different initiatives, and we try and keep that up to date as much as possible. We have an interactive guide, which I think we're about to update if we haven't already. And it says what it is really. It's very much an introduction to the topic of plastics in construction. What can we do about it? What are the drivers? A bit on the regulations and legislation as well. And what we are doing very soon is going to have a really nice interactive graphic on our website. We're going to start with a house. We may possibly move into other different construction types as well. And this is really to sort of highlight some of the substitute products you can use. So hopefully we'll showcase the ones that you've heard today, both looking at exterior and interior, providing information on those products, issues to consider, and links to other information that we have. Do get involved. You can see there are some costs to the plastics group, but that keeps us running, so it's very well worth the money. There's a survey going to come out very soon once I've finalised it. It would be great if you could fill that in, because that would help us look where we're going to do some more activity in the future, and also get in touch if you have innovative products. Always happy to hear about them. And that is us. Do get in touch. We're a very friendly bunch. And Larry's not on there. I apologise to Larry. I need to add you on. Right, that's me done. Thank you.
Thanks, Catherine. Sorry about that. I've managed to lose the screen there entirely. Okay, so thank you so much, everybody, and thank you, audience, for staying with us. So here's our poll. The audience are going to fill this in, and we will ask you to pick. You're only allowed to vote once. No cheating now. I'm not sure. Can you game the system, Richard? I'm not sure.
Hopefully not.
No, I don't think you can. You'll probably crash it if you try and vote more than once. So no cheating. In this preamble, in this moment, the judges have had a little bit of time to think about who's going to win. So I'm going to ask our judges now to take in turns to give their decision. I apologise for forcing you to make a decision, because everybody should win, I think. But Julie, I'm going to start with you. We'll come back to our poll, shall we, in a moment, Richard? And so Julie, perhaps I'll go to you and ask you to say, who do you think out of all of those should win?
I would like to vote for egg lighting. Okay, thank you very much. Would you like to just give a sentence on why? Yeah, I do think it's one of the most innovative. It's still ready, and I really like the job creation aspect and just reducing waste in general while still improving performance. And I thought the presentation and the way the questions were answered were really good and quite transparent. Okay, fantastic. Thank you, Julie. Neil.
Good for a lighting business.
Thanks, Simon. Yeah, it's a horrible thing to have to make a decision, because
I know,
all these,
I'm so sorry.
All these products are very much, they're all complementary, and I want to have them all, but I have to pick one. And I too am going to pick egg lighting, because I love the way that it keeps products right at the sort of top of the pyramid, and it remanufactures them. I've not come across that phrase, but I think, yeah, the innovation side of that comes in as well. So that was the one that sort of stood out, because it really, yeah, it's a big personal bugbear of mine, waste, and I think that just, yeah, stood out for me.
Okay, thank you very much. Mark, over to you.
Can I just thank all the entrants, by the way, and I hope everyone's got some good profile and learned something through the process. And if I could, I would give one more than one prize. But I'm going to do this like they do in the TV. I'm going to award this company my vote, because I think it's an area that could really benefit from some awareness, and also not just that I like the philosophy of the company, but I like the way that they demonstrated a generosity of spirit in terms of building a greater philosophy of remanufacturing. So for that reason, I would give egg lighting my vote as well. Okay, well, thank you so much. So that's unanimous from the judges. And now drum roll, drum roll. So as far as our audience is concerned, they disagree with the judges completely, which I'd love to see. And so Biome has come out on top of our audience vote. So congratulations, you guys. I mean, as far as I'm concerned, you're all winners. So yeah, there's a marvelous prize and a range of activities that we want to work through with you. So thank you all for taking part. It's been a really great afternoon. It's been pretty fast flowing, but I really enjoyed it. I've learned quite a lot, and I feel like I've got to know all of your products better. Thanks to the audience for staying with us. Thanks to the judges for your careful time and considered attention. And thanks, of course, to our pitchers for all of your time and all of your efforts. So thank you ever so much, everybody, and cheerio.